Alrighty guys, so welcome back. You probably just watched our previous video. We are going to jump into the impacts of mining now. So if you guys remember, this was actually a fun lab that we did with your cookie mining lab where I gave you all chocolate chip cookies and got you hyped up on sugar, and you mined the little ores out of them, which were the little candy chocolate chips. And you weighed out your chocolate chips, and then you did your overburden, and you did your reclamation of your mines. That was a really good activity. So we're just going to go over mining really quickly. And as we're going through this, I want you to keep that activity in mind, and I want you to think about that activity when you do your FRQ for the day as well. All right, so as the more accessible ores are mined to depletion, so that means once they're gone, mining operations are forced to access lower grade ores. Now, if an ore is lower grade, that means that it's got actually less metals and minerals in it. So you guys figured out the grade of your ore by weighing basically the amount of chocolate chips or the good ore versus how much of the actual like cookie you had. So the more of the chocolate chips you had in like your mine, the higher grade ore it was, because the higher percentage of ore per like square of land it was. So lower grade ores just have less metal in them and less minerals. So accessing the ores requires increased use of resources that can cause increased waste and pollution. So we're using more machinery to get to those lower grade ores in an effort to still make a profit. But the use of the machinery, obviously you're combusting fossil fuels, so you're putting more CO2 into the atmosphere. When we talk about surface mining, and that's what this picture is of right here, that's the removal of large portions of soil and rock called overburden. So removing the stuff that doesn't have the mineral in it, it's kind of like waste or discard in terms of mining, and that's the overburden, in order to access the ore underneath. So the example here is strip mining, which removes the vegetation from an area, making the area more susceptible to erosion. Why would getting rid of vegetation in an area make the soil more susceptible to erosion? Why do you think? Sorry, I paused to let you guys think about it. It's because vegetation has roots in it, and we know from soil erosion that the vegetation allows those roots to grow and anchor, and it helps prevent the soil from going away. So mining waste includes soil and rocks that are moved to gain access to the ore and the waste. These are called slag and tailings that remain when the minerals have been removed from the ore. So you guys are probably going to see it as tailings more than you would as slag, but just know that slag is another word for that. Mining helps to provide low-cost energy and material necessary to make products. So, copper, aluminum, coal, right, for coal burning plants for energy. The mining of coal can destroy habitats, contaminate groundwater, and release dust particles and methane. Remember, mining coal and burning coal are very dirty processes. As coal reserves get smaller due to a lack of easily accessible reserves, it becomes necessary to access coal through subsurface mining, which is expensive and also more damaging to the land, because when you talk about subsurface mining, you have to drill down into the ground and get further down to where those coal deposits are. Again, coal is not clean energy. It causes a lot of detrimental effects. So just a couple things I'm going to mention. I think, yep, that's it for this week. But those tailings and waste from coal mining have sulfur in them, okay? So this is going to be important because when sulfur reacts with water or rainwater, so like if there's a lot of tailings out and exposed and it rains a lot, the sulfur can react with rainwater and form sulfuric acid, which has the chemical compound H2SO4, right? And that's not good for an area, right? So if the soil becomes more acidic, then let's think about some of the consequences that could happen, right? So if we have sulfuric acid in our soils, we know that vegetation has a happy pH balance, right? Just like humans, all living things like to maintain homeostasis. So if the soil becomes more acidic, vegetation can die, so we'd have reduced plant life. acid is very corrosive, so it can like corrode roadways and also get into water supply, like groundwater supply, and contaminate water. So if you live near a coal mine, a lot of people do have health issues. Now, if we think about ways to mitigate against that, to mitigate against the acidification of soils, think about the lab we did with the acid rain in the lakes. Limestone is a natural buffer. So you can add limestone to an area to buffer out that sulfuric acid. Also, bases, other bases can be used. So when we think about bases, typically they end in an OH. And when I say base, I mean on the pH scale above a 7. So also other bases could be like sodium hydroxide, so NaOH, and then calcium carbonate as well, which is CaCO3. So that's just something to keep in mind. And also think about ways to reclaim mines. And I'm telling you this, I'm going over all of this with you because you're about to see an FRQ that has to deal with some of this information. When we think about reclaiming a mine, there are different ways to do it. One of the ways is just to try to like recontour the land and regrade it to how it looks naturally. You guys did that in your lab where you tried to like push your cookie back into the middle, right, of your prescribed little area. Also, you can plant vegetation to help the roots take place and to help prevent soil erosion. And you can monitor an area. So when mining companies go in, when they have to do like land reclamation and whatnot, they can monitor it for like, it's typically like 5 to 10 years to see if there's anything additionally that they need to do. So that's just something to keep in mind. This is going to be the end of your lesson for today. What I want you guys to do is go into your AP environmental books, which you all should still have, and you guys are going to read up on the mining portion. So I put the actual page numbers in the assignment. I listed that. You can kind of skim through it because you should have read it already, but you can kind of skim through it, and I would do that before you start your FRQ. I have the FRQ listed as just like one big chunk of like a quiz. So like if you open it up and you click start quiz, your FRQ will pop up. All of the components will be there in a picture, and it's going to be a text entry. So you do your entire like typing in like the one text entry box. There's not multiple ones. It's just in one. It is timed. So you'll have 25 minutes, which is what you're going to get on your first FRQ on your AP test. But you'll have 25 minutes, only one attempt. So that's why I said make sure you kind of go over those mining pages first so that you can kind of have a little bit more of a head start on your FRQ. We're only going to do one attempt. We're only going to do 25 minutes because I do want you to get a feel for what it's going to be like on your actual AP test, and kind of let you know kind of how quickly you need to be working. If you don't get it all done, don't freak out. It's not going to affect your grade negatively. So the grade that I give you, I just want to see where you are and kind of what's going on. So if you have any questions, let me know. I'm going to be posting up some important announcements really soon, so be on the lookout for that. I hope you guys have a great day, and if you need anything, reach out.